On November 7th, 2018, Hardware Massive put on their first annual Hardware Summit in San Francisco. CEO of Hardware Massive, Greg Fisher, was on hand to kick off the event and to explain the Valley of Death to the uninitiated.
We do Hardware Con every year in April, and we had a lot of demand and excitement for more events. So we decided to put it together and see how it would go, and I like the energy. Thanks for coming. It's looking like a good turnout. And the value basically is, you look at the financial graph, right? And you start at zero, and you put money in, for prototyping, development, then you get into tooling, and then you get in the first manufacturing run, and then before you receive the money from your sales, you get into the second manufacturing run probably. So there's the valley, and then you get some money from sales back, and start climbing. And if you can get to that break-even point, if you can get to cash flow positive, then you are probably 80 times better off than where you started at the beginning. Much better probability for really making it to the end goal.
The first panel was on methodologies for scaling to production. The experts on this panel have seen a lot of mistakes from a lot of different hardware startups.
We have an amazing panel of experts to talk about the issues around the Valley of Death. And I think that you all know that 9 out of 10 startups fail. A lot of them fail for the same reasons, right? And so there are lessons that our panel of experts will be able to share with you today as we talk about the special needs for not only every startup, but particularly for product-based startups, where we have issues around cash flow, product timing, logistics, post-production, and the like.
In my opinion, the Valley of Death really begins when you start to take your product from the concept and the proof of concept to mass production, because a lot of development is done just to prove that the technology works, and it's not really done with an eye on how is this going to be produced in mass and at a good price point and at a quality and reliability level that's going to be applicable to the consumer market. And it's a bit of a challenge. A lot of designers are not manufacturers, and they don't design with manufacturing in mind, and that ends up being very expensive down the road when you're redesigning, you're trying to go through mass production. So it really begins when you have to start turning that concept, that technology into a marketable manufacturing product.
So we have a lot of experience with this Valley of Death in the product development space that we live in. What we hear so many times from startups is, we're 90% done. And they never are. Usually they're 10% done. Having a working single unit of what you want to have is very different from having a fully designed, vetted, validated design that's ready for tooling. So the Valley of Death for us is people that underestimate the amount of time and effort and cost that has to go into taking what you have that's working and making it manufacturable in volume.
At early stage hardware startups, oftentimes the business model can also be a little bit half-baked, and we see that a lot with connected products, because oftentimes connected products have recurring costs associated with them in one form or another, whether you're buying services from an IoT vendor or you're spinning it up yourself. And there's also oftentimes a twinge of optimism in there, right? So about a price point maybe that a market's willing to absorb, how initial demand and price sensitivity for your product will scale. So I see it as this combination of generally insufficient expectations around costs, both dollar costs and time costs, and insufficient testing and resolution around the business model, which will be the tool that pulls you out of that valley and helps you overcome those fixed and variable costs.
My view of this is jaded by being a little bit later stage, right? So product's already been prototyped, developed, ideally mass produced by the time it reaches us. Unfortunately, that 90-10 rule, I think, definitely applies to us as well. Of the close to 100 hardware startups we work with at any given time, eventually, practically all of them will have us pull all the units off the shelf at some point or another and manipulate that product in some way in the warehouse. But the distribution network that you build, whether it's one warehouse or several around the world, needs to be really flexible, really agile to handle that. You know, we're constantly flashing firmware, swapping components, dealing with packaging issues. It's always the thing you didn't think about, of course. And so we think about it in the Valley of Death and some of the major challenges in kind of two ways. One is product related, which is those types of issues. The other when it comes to product is really when it comes to returns management. Across all the hardware startups we work with, our average return rate is about 10%. And that includes some really early stage startups. That includes some companies that we've been shipping for 8 years, 10 years with, right, as they go into that average. But I think that surprises most people. I get a lot of entrepreneurs coming saying, hey, we're ready to launch, we're looking at costs, trying to model everything out, and by the way, we're projecting a 3% or 5% return rate, and it's like, well, that's great, but you know, that Wi-Fi connected device with robotic elements in it in a brand new product category that nobody understands is probably going to see a higher return rate than 3%, right? So that's one thing people definitely don't see early on, I think. The other is channel, and that gets really difficult when you have a very successful pre-order or Kickstarter campaign, and I'm kind of focusing this on consumer products for a moment, but these companies often think, okay, great, we've got validation, we are a direct-to-consumer play, we're going to continue taking orders on our website, and you start to see the momentum wane. PR, press wanes, the volume starts to drop off. You have retailers or distributors or other really creative, interesting sales channels knocking on your door saying, wow, I think you have an amazing product, we'd love to carry that product, we'd love to sell that product for you to our customers. And it's really hard to turn down a lot of those opportunities because you start to feel the direct-to-consumer volume start to fall off, you're looking for other opportunities anyway, and here's somebody with a really exciting opportunity. So most of our clients, this isn't true for everybody, but most of them end up going 90% maybe direct to consumer or direct to end user, and then within 6 to 12 months after shipping the first unit, we're shipping 90% to indirect channels. You know, that's the product you end up seeing on Amazon or at Best Buy. And then when you compound that problem with the fact that now everybody who's out raising money probably has some sort of subscription element or some sort of refill play that comes with the product, you know, how do you convince Best Buy that, hey, you're gonna sell this device for us, but now there's this subscription element or recurring revenue stream that you don't have a good plan for them to partake in. Maybe you don't want them to partake in, right? Or maybe you do, but those are really difficult challenges to figure out.
Just a little reminder, this panel is about it's called our Gear panel, and it's all about the new tools and technology that have come out in the last 2 to 5 years that are changing the game and that startups should be aware of to implement.
Where do you see startups struggle the most when they actually are past the prototype stage and they are now going to produce their product?
Obviously I'm biased, but in documentation. A lot of, especially less experienced engineers, just don't know what that format is of their CAD files, of their bill of materials that contract manufacturers expect. Anything from part numbering to part naming to revision labels. And what ends up happening is the manufacturers spend a lot of time cleaning up the BOM. And in fact, they hire staff specifically to do that, and it leads to delays, like emails back and forth. This part's not available, I don't understand this, what is going on here? Your part name is screw that Joe knows how to install, right? Like, I can't use that. And so a lot of people fail, or at least see delays in the documentation.
To back that up, I worked with hundreds of hardware entrepreneurs throughout the years and had my own startups in the space, and documentation was a big one. I think many of the early stage companies, depending on what technology readiness level they're at, are over-reliant on supply chain contract manufacturing partners. I also found that one of the biggest mistakes that early stage hardware companies have is that they rush to production, or they rush to beta prototypes to get in the hands of customers. And typically that also means making the wrong decisions, not really thinking through the material, tooling, and manufacturing process trade-offs. When you make a decision to go to plastic or metal or composite, it's a different cost structure. The other thing I've noticed is not enough engineering validation of the product before it goes to market. So they don't account for very simple things like my product needs to go through different temperatures, humidity, vibration, and then the product fails in the field, of course.
You know, we're out here building tools to make bringing hardware to market easier. Use them. I mean, you know, whether it's documentation control or whether it's stuff to get you through the valley of death, leaning on the software industry metaphor, you don't see the software guys writing a new programming language up from binary through assembly up to an actual language with syntax just to create a new web app. You don't want to be thinking about, you know, how you're going to build a hammer when you want to build a table. And so I understand, you know, again, the siren song of the spreadsheet. The temptation is strong to be scrappy and to use minimal resources, but you have to remember that as a startup, your time is actually the most valuable resource that the startup has.
It started with kind of iRobot. Well, Disney really kind of originally, but 10 years basically at iRobot, leading the different versions. What do you feel like, let's say 5 things you did wrong and 5 things you did right?
Yeah, well, and definitely a lot to choose from. We really screwed up a lot of stuff and somehow managed to survive. But thinking through it, one of the experiences that really stuck with me is and this is like in the late 90s, early 2000s, we've been at work on the Roomba for about 5 years. And we're just really like pinning all our hopes and dreams on this thing taking off. And I was living in China at that time. I think we built up about 5,000 units and we're getting ready to ship. So these were the first 5,000 units after 5 years of work. And we probably tested them maybe for about 5 hours on a good day. And I just remember sitting in down for breakfast in this amazing hotel where they actually had like a glass atrium with white tigers, literally like running around that we always used to watch, and thinking like, you know, we should probably test it a little bit more before we ship it. So we tested it for what was about 8 hours and found that in 100% of the units there was a catastrophic failure. So had we shipped that batch, like they all would have come back, and that's not a lot of fun. And so testing is good. You know, we often think of the manufacturing triangle, which is cost, quality, and schedule. Everybody's always worried about cost first because it's the most mathematic and measurable. It lets you know if there's a business or not. And then they start worrying about schedule, like, oh my gosh, the holiday season is coming, we've got to get this shipped. And it's always quality that suffered. And what got us in this instance was we had built a wheel module, you know, that would drive the robot around, and we used a rubber belt, figuring if somebody, you know, holds the wheel still, the belt will slip and things will be fine. Well, what we had done in terms of that drivetrain is created a brass shiv, like a V, sort of a V pulley to drive the belt, and hadn't realized that we should specify how smooth the inside of that V belt was. It was just a machining process. And as a result, the shiv that we had, you know, little, really small machining marks. But if you've ever looked at a V-belt and how it works, there's a scrubbing action. And what happened is when this thing drove around, it created just a phenomenal amount of like black sawdust inside from the belt to shave the belt down, which, you know, ordinarily not a big deal. But with us, we had also built our own encoder, which measured the odometry of the robot. And Murphy being who Murphy is, there's an electrostatic force that grabbed all of that black dust and threw it right on top of the optical components. So, and then the robot had no idea where it was just flying blind. And of course it took, you know, about 8 hours, not 5 hours for this to happen. So, oh, we realized really quickly this is not good. And we'd already built up 5,000 units, which at the time seemed like a lot of units, and this was our first launch. So the good thing is like 100% of the units had this problem, so it was never like, can we get by with it or not? We were like, no, we gotta fix it. But then the problem is, you got 5,000 units and they all have this problem. And usually to change the tooling, you have to take the tools and machine them or modify it and put it back again. But with this, there's just no time to do that. So we're like, geez, how do we solve this? And we got really lucky that we looked at the different manufacturing technology and realized that with a film, you can make a really quick die cutter in about half a day. So think of like a big cookie cutter to die cut basically a film that we shoved in because it was so thin, like a plenum, and that kept the dirty dust on one side and the encoder clean on the other side. So we were able to go do that and rework the 5,000 units. But it was like a good reminder, like, you know, quality is definitely the unsung hero. And we were crazy for not testing the thing longer, but we just didn't have a stable platform, so no chance to do that. Yeah, it was a whole like different world in that up until 2009 it just wasn't accessible for companies to go and build their own hardware. So we did what everybody does and used Excel. There's no Google Sheets at that time to manage the bill of materials. And again, the room was complex enough and we had no clue what we were doing. Like most of us had never built anything in volume before. So you'd get releases to the factory where it'd be like, final release for the wheel drive housing. And then you'd realize there's a mistake. You'd be like, oh, final release 2. But then that didn't quite work. So then you get like really final release.
Final, new, old, these are terrible ways.
Yeah, and there's no version tracking in the spreadsheet. So you really, at the end of the day, like we didn't know what product we had built. If somebody said, Scott, you got to move this from the factory you picked to another factory, like there's no way in hell we could have done that. In fact, it was so fast and loose. And again, the design was just not fully baked. We were still trying to figure it out. Which made it harder for people to copy, because if we couldn't build it, then it was harder to knock off. But we would often on a Friday night, like at 10 p.m., have some problem and be like, all right, well, we got to change the tool. So we'd pick up the tool, overnight we'd bring it to the tool shop, they'd EDM in some new river feature and bring it back and shoot the plastic in the morning. But to what Michael was saying, like none of this was documented. Like there's not in the database, not in the Excel file. So at the end of the day, like the only way to figure out what was being built was to do a laser scan of the room if we wanted to duplicate it. Like, you just couldn't make another one. So eventually we're like, all right, this can't stand. Like, we need better tools than Excel. And then there's a lot of email back and forth and things like that. So we decided to put in a couple tools. One was Windchill, which is a Pro-E, which is a CAD we used back then, sort of a Pro-E PLM, PDM type of thing, with a lot of very, very rigorous procedures for coming up with like engineering change notices and checking off all this. And then we also put in Oracle. And pretty much at that point, like progress stopped for a year. Like we just couldn't get out of our own way. And it's not that they're bad tools. Like if you're Apple, they're amazing, and I don't know how you'd ever manufacture anything with them. But they were just totally the wrong thing for us. Like we had to hire people to be full-time staffers at iRobot just to manage the tools. The engineers had no clue. Like we just couldn't build the product. And going from being super nimble to like having our hands tied was incredibly frustrating. Which is why I get so excited today for like the new tools that are built on modern software. You don't need to take training classes, you don't need to hire people. They're not anywhere as onerous to use as Oracle, but they're better than spreadsheets. And as we talked about, there's a whole host of them, but I wish that stuff had existed a long time ago. So, it's a really fun journey, and there's like no bigger rush than going to a store and seeing something you built on the shelf. So it makes all the like blood, sweat, and tears worth it. Like I like software, but it's like something you can hold in your hand and you can't go away. So it's worth it. But I think of it in two ways that are related. One is there's a lot of unknown unknowns, and those are the things that are going to kill you. So try to figure out what you don't know, which is a little bit of an oxymoron, but talking with people and trying to like get a list of things that could possibly happen. And then once you've got that, it's all risk management. And
to learn about other upcoming events in the hardware space, go to hardwaremassive.com. And to check out the full article on this event, see solidsmack.com.